Hello everyone and welcome back to the Leetcode grind. Today we have 1930 unique length-3 palindromic subsequences. It says here, given a string S, return the number of unique palindromes of length 3 that are a subsequence of S. Note that even if there are multiple ways to obtain the same subsequence, it is still only counted once. And just to review, a palindrome is a string that reads the same forwards and backwards, like ABA, AAA. And a subsequence of a string is a new string generated from the original string with some characters, and it can be none, deleted without changing the relative order of the remaining characters. So if we have this source, then we can take like ABC, or we can skip the B and do ACE, but we couldn't do something like A and then jump to D and then jump back to B. Okay? And then it is 3. So this is actually quite simple. We are looking for exactly length 3. That makes it simple. And the approach that we can take is by grabbing the unique chars within the string. And because even if there are multiple ways to obtain the same sequence, it is only counted once. For instance, here we have 1, 2, 3, 4 B's. So we can have a BBB using this, and this char, this, and that char. There are different indices, but they still generate the same BBB, so BBB is considered only once. So let's see, BBC, BABA. Let's actually use that one. BBC, BABA. BBC, BABA. So if we grab the unique char, so far we have, we can see it's A, B, C. So A, B, and C. Those are our unique chars. Then we can go through the unique chars and say, okay, what's the leftmost appearing A? And then so for that we actually need indices. So 0, 1, 2, 3, 4, 5, 6. Okay, so the leftmost A occurs at index 4. And the rightmost A occurs at index 6. Then, between 4 and 6, how many unique palindromic, forward and backward same, 3-letter subsequences can we generate? Here it's ABA. So let's add to our result set. And we want it to be a set because we want just the unique ones. And let's use this color. So A, B, A. Great. So we're done with A. Now let's go to B. A is done. B. What's the leftmost B? B is at index 0. What's the rightmost B? Well, that's at index 5. And let's remove this guy and say, okay, so between 0 and 5, we can go through every character in between 0 and 5. So it's really just this. So between the range of index 1 to 4, what can we generate? So B, 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 that works. So let's add that to the list. B, B, B. What else? It's B, C, B. B, C, B. And then, B, B, B. but that's already in here, so we can add it, but it won't be really added. And then BAB, BAB. So notice that we have the left range and the right range, and because we're guaranteed, or the requirement is to find the 3-letter palindrome, and the first and the last, just by how we're approaching this, they are matching. Any letter in between will satisfy the requirement. And by using a set, that'll handle us not duplicating results. So there we go. So BAB, we added that here. And that means this is also done. And then let's move on to C. Okay, so what's the leftmost C? Well, the leftmost C is here. That's at index 2. What's the rightmost C? Rightmost C is still here. Now we want to go in the range between the first appearance of the character and the last appearance of the character. Well, there's nothing between 2 and 2. 2 is equal to 2, so there's nothing to do, and this is our result. 4. And then all we have to do at this point is return the length. ABA, BBB, BCB, BAB. And that matches ABA, BCB, BAB, ABA, different order. Result of 4. So now we can implement this, and going back, we have a result set, and we're going to return its count. Okay, so let's say result, or let's just say vowels. This is going to be a set. And now remember, we care about the unique instances of the chars. So let's get that. Let's say the chars will be the set of whatever our input string is. Then for every char in chars, so for every unique char, we want to know what's the leftmost one. So s dot index of this char, and what's the rightmost one? We can use that using r index of char. That'll just give us the rightmost index of the occurring char, which may be the same as the first index. So in the case of C, in this instance, it'll just both return 2 to this index. Okay, and then we can say for the range, for I in range between L plus 1, because we don't want to include the left bound that's going to be used up in our resulting 3-letter substring. We're in the range of that to R. This is non-inclusive. We add to vowels the string generated by adding the char plus the character at this index position plus the char again. And remember, by this point, we'll have the vowels, which are all the 3-letter palindromic subsequence strings found from here. And from there, we just return the length of vowels. And we can give that a go. And the submit. And there you have it. Once again, this was 1930 unique Length-3 palindromic subsequences. I can see that we're doing this in linear time. And for the space complexity, what would that be? It's not constant. I guess at most it's O of n. Please comment below if you know. Thanks so much. Happy coding, and see you next time.